Let us learn a multiple choice question from electrostatics. Four Gaussian surfaces are given below with charges inside each Gaussian surface. Rank the electric flux through each Gaussian surface in increasing order. So there are four options given here. So let us check the solution and find which one of these four is correct. The path. The path is the subject here. So we have to know what is the definition of Gauss law. The Gauss law states that if a charge Q is enclosed by an arbitrary closed surface, then the total electric flux phi through this closed surface is equals phi E equals integration closed surface E vector dot dA vector equals Q enclosed by epsilon naught. So I read it again. This is a little important definition. Gauss law states that if a charge Q is enclosed by an arbitrary closed surface, then the total electric flux phi E through the closed surface is phi E equals integration closed surface E vector dot dA vector equals Q enclosed by epsilon naught. So this is what we are going to use in our solution part, the solution. So we simplify the equation phi E equal to Q enclosed by epsilon naught. Now let us take the first surface A. The charges enclosed by these surfaces A are, let us look into it. So the plus 2Q is there, the minus Q is there, and plus Q is there. All these three charges are enclosed by surface A. So the formula become phi A equals plus 2Q minus Q plus Q by epsilon naught. So after a simplification, phi A equal to plus 2Q by epsilon naught. So let us go for the surface B. The surface B encloses two charges. One is plus 2Q, the other one is the minus Q. So here you have a charge plus Q, which is outside the closed surface, which will not contribute anything to the flux coming out of the closed surface B. Remember it. So we have to consider only the charges enclosed by surface B, which are plus 2Q and minus Q have to be considered. So phi B equal to plus 2Q minus Q by epsilon naught. After simplification, we get phi B equal to plus Q by epsilon naught. So let us go for the third surface. The third surface phi C, which encloses two charges. One is plus Q, the other one is the minus Q. The other two charges, okay, other one charge plus 2Q is outside the closed surface, which will not contribute anything to the flux coming out of surface C. Let us not consider plus 2Q here. So plus Q minus Q cancel each other. The flux through C equals 0. So let us go for the other one. So flux through the closed surface D. So the closed surface D encloses only one charge, that is only one charge. It is minus Q. Other two charges are outside the closed surface, so they don't contribute anything to the flux. So the answer here is phi D equal to minus Q by epsilon naught. Let us take this value as minus X, and let us take this as 0, and let us take this as plus X, and let us take this as 2x. So if you keep all these in increasing order, you get minus X is the least, and the 0 is the little higher, and plus X little more higher. So the highest is the 2x. So the answer is phi D less than phi C less than phi B less than phi A. So this sum can be solved with no time, because the phi E directly proportional to a Q enclosed as epsilon naught is a constant. So it is a constant. So let us work out directly now. So the enclosed the proportional to plus 2Q. The flux through closed surface is proportional to plus 2Q. Through the B, it will be simply plus Q. That is what the net charge enclosed by B. Then closed surface C. The flux through closed surface is proportional to 0, because net charge is 0. So the D surface, the flux proportional to minus Q. The proportional to minus Q. So now you go with the increasing order minus Q, 0 plus Q plus 2Q. It is the way. So with no time you can solve this problem once you understand it and keep epsilon naught as constant and flux proportional to the total charge enclosed to it.